Well, hi there. Today we're going to talk about Lesson 56. Lesson 56 includes working with and plotting functions. Now you say, what in the world is a function? Well, we're going to talk a little bit about the vocabulary of functions. Function is a mathematical rule defining the relationship between two sets of numbers, usually an x and a y. Okay? Function rules are equations, usually. Okay? Usually you will find if there's a function, there is an equation, and it's usually an equation that has to do with x's and y's. Occasionally they change the variables, but functions are generally graphed, and so they have to get along with a coordinate plane. We are going to plot functions as coordinate grids. We are going to look at a coordinate grid that's already been plotted and see if we can figure out the function from that. Here is an example of a real-time problem that can be solved by using a function. Jamal is ordering chairs for his restaurant. The function table below shows the number of chairs he orders for each table. Now, when you're trying to set up a function table, you're going to have the input and you're going to have the output. The input is usually signified by the x, and the output is signified by the y. Generally, something happens to the x to create the y. So, if you have tables, then you need chairs. For one table, how many chairs do you need? So, we look at the grid. For one table, you need 4 chairs. For 2 tables, you need 8. For 3, 12. For 4, 16. Can you see the relationship? Yeah. The relationship is for every table, you have to multiply it and you get 4. 2 tables, you're going to have 8 chairs. 3 tables, you have 12. 4 tables, you have 16. And of course, if you're looking at the rule, you're looking at the function. If you have x tables, you have 4 times x chairs. So, let's look a little further into these functions. Okay, to be able to write a rule for a function, you must be able to do the following. Write the rule in words. That means you tell us exactly how many chairs Jamal wants for each table. So I wrote that right here. To find the number of chairs, just multiply the tables, which we're using x to signify the tables, by 4 chairs. Okay? And when you do that, you get your y. Then you have to look at the function table. I'm going to move this down so if you're still writing, you can see it. You look at the function table to determine the number of chairs needed for 5 tables. Based on the table, we can take 5 times 4, because that is our function, 4 times whatever the x is, or x times 4, and we get 5 times 4, which happens to be 20. So we would have, for 5 tables, we would have 20 chairs. Lastly, we can write the rule of the function as an equation. Now we're going to use the letter y to represent the number of chairs and x to represent the number of tables. So here we go. Y, the number of chairs, is equal to 4 times whatever x is, the number of tables. But when we do that, we create a little function table. So, we take the values from the function table to create a graph on a coordinate plane. Alright, here's our function table. We had it on the previous sheet, but I repeated it. Here's the input, x tables. Here's the output, y chairs. And to get chairs, we have to take x times 4. So if we have 0 tables, we'll have 0 chairs. 1 table 4, 2 tables 8, 3 tables 12, etc., 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 etc. This function table gives us the following coordinates to graph on our coordinate plane. We have 0, 0, 1, 4, 2, 8, 3, 12, 4, 16, 5, 20, and we could go on forever. Whatever we would put in for x, it would be 4 times it. So I could go on to 4 million a million tables, 4 million chairs. That would be a little hard to graph on this graph, but we could do it if we needed to. So if we look at the coordinates that we're given, let's graph it. Let's graph it, okay? So we have 0, 0. So we're going to look here, and I think what I'm going to do is blow this up just a little bit so that we can see what we're doing more easily. So we have 0, 0. So I'm going to put a dot on 0, 0. That's the origin. Notice I don't have any other quadrants, and I'll explain that later. Okay, then the next one here is 1, 4. So you go to the right 1, because that's the x, and you go up 4. 1, 2, 3, 4. So this is 0, 0. This one is 1, 4. And then you have 2, 8. So we go 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. This point is 2, 8. Then we have 3, 12. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is point 3, 12. Okay, 4, 16. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Here's 4, 16. And then we have 5, 20. So we go 1, 2, 3, 4, 5. And then we go all the way to the top of this graph because we see that the last number on it that they have on there is 20. So we have 5 points. 1, 2, 3, 4, 5. Actually 6 points, with the last point being 5, 20. They look like they're kind of in a line, don't they? Well, the fact is they are in a line. And now we can connect those points together because this is a linear equation, meaning that all of the answers are on this line, okay? So, if you were to pick any answer that showed up on this line, I don't care where it's at, if you could pick the point off the line, it would satisfy this linear equation of y, this is y equals 4x. Any point on that line. Now you notice the line doesn't go below 0. That's because you can't have negative tables and negative chairs, right? Can't have that. Okay, let's do the next example. This one hopefully will make some sense to you. Alright, for every necklace Joni buys, she purchases 2 earrings. It says set up a function table to help us see the input and output, x and y. Okay, here's our function table. If we have 0 necklaces, we have 0 earrings. If we have 1 necklace, we end up with 2. If we have 2 necklaces, we end up with 4 earrings. 3, we end up with 6. 4, we end up with 8. Da 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 da. X necklaces, 2 times x earrings. So this function rule is y equals 2 times x. Whatever you have for x, you double it, and it becomes y. The coordinates of the table are, and you can see this if you just look at it, you've got 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, on and on and on. So, let's graph it. Let's graph it. Okay, we're going to enlarge this again so you can see it. Okay, we're graphing 0, 0. Again, this starts at 0 because you can't have negative necklaces, you can't have negative earrings. 1, 2, 1, 1, 2, 2, 4, 1, 2, 1, 2, 3, 4. So this was 0, 0, this was 1, comma 2, this is 2, comma 4. I like to label your points so you're sure what you're doing. 1, 2, 3, 6, 1, 2, 3, 4, 5, 6, 3, comma 6, and 4, comma 8. So we go over to 4, 1, 2, 3, 4, 5, 6, 7, 8. Now, could I have picked out more? Yes, I could have done a ton more, but I didn't. Now, notice how I graph this. I've got my points here, right? I know what my points are. I've got them right here. When I draw my line, I'm not going to stop at that last point. I'm not going to stop at 4, comma 8. Okay, I'm not going to stop there. Why? Because this line goes on indefinitely. Okay, it goes on forever. If she had 1,000,000 necklaces, she would have 2,000,000 earrings. Now, we're not going to show it on this line. Obviously, it doesn't go that big. But this particular line is the graph of y equals 2x. So I want, this is the first one I've actually labeled it this way, but I'd like to see you, when you draw graphs, label them y equals 2x so we know what that graph is. We could have gone back here on this previous one and done the exact same thing and labeled this y equals 4x. Okay? You should always do that. You should always take your lines out to the edge of the paper. Okay, so we did that with this one and we labeled it. We have our points on it. We're good to go. Okay, let's look at this. Okay, and this is something I've already kind of talked about. Notice that the previous two coordinate planes have only dealt with the first quadrant. Why is that? Well, the reason is best explained by the problem. Could we have negative tables or chairs? No, not quite. Would we have negative earrings or negative necklaces? No, not going to happen. So, some functions don't involve negatives. Some functions do. Some functions that are just numbers, basically, we don't have to worry about whether they're negative earrings or negative chairs. They're just a function. So we can set these up in a way that really helps us find coordinates. Let's say we have a function y equals 3x. They've given it to us. Okay? We're going to set it up in a table here, which I think really works well for beginners. It actually has 3 parts. Okay? The first part is the input, the x. I always put the rule in the middle, y equals 3x. Okay? And then the output is over on the right hand side. So you've really got 3 parts for it, because then you can operate on it. And I mean operate it by substituting in. So x is 0. Y equals 3 times that 0. The output is 0. X is 1. Y equals 3 times that 1. The output is 3. X is negative 1. Oh, we haven't run into that yet, but we can do negatives on this graph. Y equals 3 times negative 1, which is negative 3. What if x is 3? Y equals 3 times 3, which is 9. And what if x is negative 3? Y equals 3 times negative 3, which is, yeah, negative y, or negative 9. We could put y equals negative 45 and take it times 3. So that's the cool part of that, and we don't have to worry about negatives on this one as far as will we graph into quadrant 3? Yes, we will, because we have some negative answers. So the function that we have here is y equals 3 times x. That's the function. It's the rule. I'll ask you often, what is the rule for this particular function? And the rule is y equals 3x. So some of the coordinates that you would have for that are right here. And I had them on a previous, so I carried them over to this page. You have 0, 0. You have 1, 3, negative 1, negative 3. 3, 9, and negative 3, 9. Now, is there more than that? Well, sure there is, but we're just going to worry about those right now. So let's go ahead and graph them. We have 0, 0, okay, 0, 0. We have 1, 3, 1, 1, 2, 3. We have negative 1. Now we're going negative, so we're going to get into quadrant 3 here. Okay, that's quadrant 3. So we have negative 1. Excuse me, got to go left first, sorry. Negative 1, negative 3. So this is negative 1, negative 3. And then we have 3, 9, so we go 3 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 3, 9. And then we have negative 3. 1, 2, 3, and negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now if you look at it carefully, I'm sure you can see the same thing that I can. You can see that there is a straight line. So we will go through and draw it. This time it goes through 0, 0 in the origin, and it continues down into that third quadrant and out. Okay, because these answers go on forever. Anything that's on this line, anything you could find, a point, this point here, there's an infinite number of points on that line. They all answer y equals 3x. All of them do. They all answer y equals 3x. Every point on that line. Nothing out here does, nothing over here does, but everything on the line does. Okay, question. Can we use fractions for x? Answer. Yes, we can. If the rule is y equals 2x, and we use 1/2 for our x, we would simply take 2 times 1/2 to find our y. And we would have point 1/2, comma 1. So yes, we can use fractions. And I think that's a pretty cool thing. I like that. Okay. Now, just one more. One more. Consider the graph below. Find 3 points on the graph where it passes through an intersection of the grid. And then write them down. Name those points. So we're looking. Now we're not, it's already graphed. The line's already graphed for us. Oh my goodness. Okay, well, we know this one right here, right? We know that's 0, 0. So we'll write 0, 0. Let's look. Let's see. This intersects at a grid. And that's 2, 1. So we'll write 2, 1. And let's see. I don't know. I'm not a big negative person, but I think I will in this case. -2, -1, and -2, -1. There's 3 points. Okay. I'm going to write them in here. 0, 0, 2, 1, -2, -1. Wow. What do you think? What's happening to these? Nothing happened here. So that 0, 0 just stays the way it is. But we have 2, 1 over here, and then we have -2, -1 over here. What's happening? What happened to 2 that it got to 1? What happened to 2 that it got to 1? What is the rule? What does y equal? Y equals, you take 2 and you do what with it? You take 2 and you do what with it? That's the mystery question for the week. What in the world are you doing to 2 to get 1? What is the number that's going to go right here multiplied by x? What is that number? So, your mystery question for the week and your bonus is to tell me what number goes in here times x to make that rule work. Thanks for listening. Come up and see me. You get some pretty decent bonus points if you answer the mystery question. Alright, so find out what number times x is going to equal y. Be talking to you later. I hope this wasn't too long, but I knew it was going to be, so there it is.